Hello students, welcome to my channel GVS Chem. In this video, I am going to explain Faraday's laws of electrolysis and some numericals based on these Faraday's laws. Please subscribe to my channel, like, share and comment my videos. In this video, I am going to explain Faraday's laws of electrolysis. Faraday's laws of electrolysis. Faraday's first law. Faraday's first law. Faraday's first law states that the amount of substance liberates at cathode during the electrolysis is directly proportional to the charge flowing through the electrolyte. So, M is the mass of the metal, M is directly proportional to the Q, Q means charge. We know that charge Q equal to current into time. Current into time. Current is I, time is T. So instead of Q, you can keep IT. M is directly proportional to IT. Or M equal to Z into IT. Z into IT. What is Z? Where Z is the electrochemical equivalent. Electrochemical equivalent. Then how do we define the Z? If I equal to 1 ampere and T equal to 1 second. I equal to 1 ampere, T equal to 1 second. 1 ampere into 1 second is nothing but 1 coulomb. Therefore, M equal to Z into 1 ampere into 1 second. This is nothing but M equal to Z. So, what is Z? Z is the amount of substance deposits or liberates at electrode during the passage of 1 coulomb of charge. Therefore, electrochemical equivalent is defined as the mass of the substance deposits at electrode during the passage of 1 coulomb of charge. 1 coulomb of charge. So electrochemical equivalent is defined as the mass of the substance deposits at electrode during the passage of 1 coulomb of charge. That is electrochemical equivalent. Electrochemical equivalent is a characteristic to different elements, different metals. That means for different metals, electrochemical equivalent is different. Now let us take an example. Electrolysis of fused sodium chloride. Fused sodium chloride means when sodium chloride is heated to high temperature, then what happens? Sodium chloride becomes a liquid, that is fused sodium chloride. Fused sodium chloride, NaCl, fused. What happens? We get Na plus Cl minus. On passing electricity. So reaction at cathode. Cathode means negative electrode. Cations means positively charged ions. So cations reach cathode. Therefore Na plus, it takes 1 electron, becomes Na. So one atom need 1 electron. N atoms need N electrons. Right. Similarly, 1 mole of atoms need 1 mole of electrons. Now let us calculate the charge on 1 mole of electrons. Therefore, charge on 1 mole of electrons. 1 mole how much? 6.022 into 10 to the power 23 into charge on 1 electron. 1.6 into 10 to the power minus 19 coulombs. So this is nothing but 6.022 into 1.6 into 10 to the power 23 minus 19. So if we calculate this 96,487 coulombs. 96,487 coulombs. This is equal to, this is approximated to 96,500. So this 96,500 coulombs, so 96,500 coulombs of charge is referred as 1 Faraday. 1 Faraday denoted by F. So this is in memory of Michael Faraday. That is 96,500 coulombs is referred as 1 Faraday of a charge. Now, as the charge on 1 sodium ion is +1, it needs to liberate 1 mole of substance. 1 mole of atoms means it is nothing but a molar mass. That is 1 mole of the substance. To liberate 1 mole of substance, we need 1 Faraday of charge. The charge on ion is 1 unit. So to liberate 1 mole of the substance, we need 1 Faraday of substance. Suppose if in calcium chloride CaCl2 gives Ca2 plus and 2Cl minus. Now what is the charge on calcium ion? Charge on calcium 2 plus ion is 2 units. Therefore, each calcium ion needs 2 electrons. Therefore, 1 mole of calcium needs 2 Faradays of charge. 2 Faradays of charge. Right. Now, equivalent weight of calcium equal to, what is the formula for equivalent weight? Molar mass by charge on the ion. Molar mass by charge on the ion. What is molar mass of calcium? 40. Charge on ion is 2, equal to 20. So equivalent weight of calcium is 20. Now, what is the molar mass of calcium? Molar mass of calcium is 40. 40 grams need. How many? What is the charge required? To liberate 40 grams of calcium, the charge required is 2 Faraday. Right. For 20 grams, we need 1 Faraday. So what is this 20 grams? 20 grams is the equivalent weight. Therefore, from this we can conclude that 1 Faraday of charge can liberate mass of the substance equal to its equivalent weight. So 1 Faraday of charge can liberate mass of any substance which is equal to its equivalent weight. Now, based on this, let us do simple problems. Now, find the charge required to liberate 20 gram of calcium from its fused CaCl2. Similarly, 40 grams of aluminium from its fused Al2O3. So this is NCERT textbook problem. Now, this we discussed just now. Therefore, this is first, second. So first one is calcium. Calcium CaCl2 gives Ca2 plus Cl2 2Cl minus. So Ca2 plus 2 electrons gives Ca. Right. Therefore, one ion needs 2 electrons. One mole needs 2 Faradays of charge. 2 Faradays of charge. So 1 mole is nothing but 40 grams. So 40 grams of calcium needs 2 Faradays of charge. 40 grams of calcium needs 2 Faradays of charge. Now how much is given here? 20. Therefore 20 grams of calcium needs 1 Faraday of charge. 1 Faraday of charge. 1 Faraday of charge is nothing but 96,500 coulombs. 96,500 coulombs. Right. Now the second one is Al2O3. So here Al2O3 gives 2Al3 plus 3O2 minus. So reaction at cathode is Al3 plus 3 electrons gives Al. So what is the molar mass of aluminum? Molar mass of aluminum is 27. Molar mass of aluminum is 27 grams. So 27 grams of aluminum needs 3 Faradays of charge. 3 Faradays of charge. Now how much is given? 40 grams. 40 grams need how many? So this is 40 by 27 into 3. Right, 3 here 9 times. 40 by 3 is nothing but 4.44 Faradays. 4.44 Faradays. You multiply this 4.44 with 96,500. That is 1 Faraday of charge equal to 96,500. Therefore, you will get in coulombs. Now let us do one more problem. How many grams of chlorine liberates at anode when 1 ampere of current passes through fused sodium chloride for 15 minutes? So we know that sodium chloride fused gives Na plus Cl minus. Now reaction at anode. Reaction at anode. Anode means plus. What ions reach to anode? Chloride minus ions. So Cl minus gives Cl plus 1 electron releases. Chlorine individual atom does not exist. Therefore 2 chloride ions become chlorine molecule. Right. So what is the molar mass of chlorine? Molar mass of chlorine equal to 2 into 35.5. Atomic mass of chlorine is 35.5 equal to 71 grams. So 1 mole of chlorine needs 2 Faradays of charge. 1 mole of chlorine needs 2 Faradays of charge. Now here charge we have to find. Charge equal to Q equal to current into time. What is current here? I into T. What is I? 1 ampere into 15 minutes. 1 ampere into 15 minutes. So this is 1 ampere into 15 into 60 seconds. So if time is given in hours or minutes, we have to convert into seconds. So this is nothing but 900 coulombs. 900 coulombs. Now come here once again. 1 mole of chlorine needs 2 Faradays of charge. So 1 mole of chlorine needs 2 Faraday. 2 Faraday means into 96,500. So to liberate 1 mole means 71 grams. 71 grams of chlorine needs 2 into 96,500 coulombs. But how much charge we have? 900. 900 coulombs of charge liberates how much mass of the chlorine. So this is nothing but 900 by 2 into 96,500 into 71. 2 zeros get cancelled. So this is 9 into 71 by 2 into 965. This is nothing but 0.331 gram. So by passing 1 ampere current for 15 minutes time, we get 0.331 gram of chlorine. Now let us do one more problem. How much electricity is required? How much electricity is required for the oxidation of 1 mole of water to oxygen, 1 mole of ferrous oxide to ferric oxide? Now let us see the first problem. 1 mole of oxygen is oxidized, 1 mole of water is oxidized to oxygen. So this is water gives O2 plus H plus electrons. So if here is only one oxygen atom, therefore if you take 2 moles of water, we get 1 mole of oxygen, 4 hydrogen ions and 4 electrons. So 2 moles of water need 4 Faraday's of charge. 4 Faraday's of charge. If it is 1 mole need 2 Faraday's of charge. 2 Faraday's of charge. 2 Faraday's of charge means 2F equal to 2 into 96,500. This equal to 193,000 coulombs. So this is the charge required for the oxidation of 1 mole of water. Similarly, second problem is FeO plus oxygen gives Fe2O3. So here 2 plus 2 oxygens plus 2 oxygen, 4 oxygens. Here only 3. Therefore this is 4 FeO becomes 2. Now what is the charge here? Fe2 plus. What is the charge here? Fe3 plus. Therefore Fe2 plus oxidizes to Fe3 plus 1 electron. That means for the oxidation of 1 mole, 1 atom of Fe, we need 1 electron. Therefore oxidation of 1 mole of ferrous oxide, we need 1 Faraday's charge. Therefore 1 mole of FeO needs 1 Faraday of charge to oxidize Fe2O3. So 1 Faraday of charge equal to 1 into 96,500, that is 96,500 coulombs. So 1 Faraday of ferrous oxide needs 96,500 coulombs to oxidize into ferric oxide. Now let us do one more problem. A solution of nickel nitrate is electrolyzed between platinum electrodes using 5 amperes of current for 20 minutes. What is the mass of the nickel deposited? So first of all, let us write the reaction. NiNO3 aqueous gives Ni2 plus 2NO3 minus. So nickel ion has 2 units of charge. Now reaction at cathode is Ni2 plus it takes 2 electrons become nickel metal. So here what is the molar mass of nickel? 58.7 gram mole. 58.7 gram mole. So as per first law, 2 Faraday's of charge liberates 58.7 grams. 58.7 grams. Now charge flowing is Q equal to IT. What is I? 5 amperes into 20 minutes. 20 minutes. So 5 into 20 minutes into 60 seconds. So this is nothing but 5 to 10, 10 6 60. 2 zeros are there. So 6,000 coulombs. 6,000 coulombs. Now here 2 Faraday liberates 58.7. 2 Faraday means 2 into 96,500 liberates 58.7. What is the available charge? 6,000. 6,000 how much? Say therefore this is 6,000 by 2 into 96,500 into 58.7. So 2 zeros get cancelled, right? Now 5 12 times 5 1 46 9 193. 2 here 6 times. So this is nothing but 6 into 58.7 by 193. So this value is 1.825 gram. 1.825 gram. So by passing 5 amperes current for 20 minutes, we get 1.825 gram of nickel. Now let us discuss the second law of electrolysis. Faraday's second law. Second law of electrolysis. Faraday's second law of electrolysis states that when a current passes through different electrolytes, when a current means same current, when same current passes through different electrolytes for same time, the ratio of metals, the ratio of masses of metals, deposited at respective cathodes, the ratio of mass of metals deposited at respective cathodes is equal to the ratio of their equivalent weights. Right. Now mathematically the second law can be represented as M1 is to M2 is to M3. If the same current passes through 3 electrolytes for the same time, then M1 is to M2 is to M3 is equal to E1 is to E2 is to E3. See here, these are the masses, these are the equivalent weights. Now how do we make this setup? The setup is, suppose this is say copper sulfate, this is zinc sulfate, and of course this is aluminum sulfate, Al2SO4 thrice. So here these are the copper electrodes, these are the zinc electrodes, these are the aluminum electrodes. Now these are connected to, this is the battery, and of course so here in this manner. So this is connected to this, this is connected to this. That means in this setup all the electrolytes are connected in series. So when different electrolytes are connected in series, and of course that is connected to the same battery, the same current passes through all these electrolytes for the same time. Right. Then second law is M1 is to M2 is to M3 is equal to E1 is to E2 is to E3. Therefore, what is second law? Faraday's second law states that when the same current passes through different electrolytes for the same time, the ratio of masses of metals deposited at respective cathodes is equal to the ratio of their equivalent weights. Now let us do one problem based on this second law of electrolysis. Now the problem is 3 electrolytic cells A, B and C containing zinc sulfate, silver nitrate and copper sulfate respectively were connected in series. A steady current passed through them until the mass 1.45 gram of silver deposited on the electrode of cell B. How long did the current pass? What mass of zinc and copper deposited at their electrodes? So this is the problem. The solution for the problem, see here, in silver nitrate container the mass of the metal deposited is given. Therefore, according to second law, second law of electrolysis. Mass of zinc is to mass of silver is to mass of copper equal to equivalent weight of zinc is to equivalent weight of silver is to equivalent weight of copper. So first of all, let us find the equivalent weights of zinc, silver and copper. So equivalent weight of zinc equal to molar mass by charge on ion. Charge on ion equal to molar mass of zinc is 65 by 2 equal to 32.5. Similarly, silver molar mass 108, charge on silver ion is 1, therefore it is 108. Similarly, copper equivalent weight of copper equal to molar mass of copper 63.5 by 2, this is 31.75. Now let us take mass of copper deposited, mass of silver deposited equal to 1.45. Now current passed equal to 1.5 ampere. Time of passage of current, this we have to find. Let it be T. Now charge equal to current into time, I into T equal to 1.5 into T equal to 1.5 T. Right. Now here silver ion takes 1 electron and reduces to silver metal. So one ion needs 1 electron. Molar mass needs 1 Faraday. Molar mass needs 1 Faraday. Molar mass of silver means 1.8. Equivalent weight. Here for silver, equivalent weight and molar mass both are same. So 108 grams of silver needs 96,500 coulombs. Okay. Now how much mass of substance formed here? 1.45. So 1.45 needs how much? So this is 1.45 by 108 into 96,500. What is the charge here? Charge is 1.5 T. Therefore T equal to 1.45 by 108 into 96,500 by 1.5. Okay. So let us continue here. So here T equal to 1.45 into 96,500 by 108 into 1.5. So here if you multiply this 145 into 965, 2 zeros are here, therefore decimal can be removed. This is 108 into 1.5. This can be written as 145 into 965 0 by 108 into 15. Okay. Now 3 here, 5 3 times 5, 29 times. So what is left? T equal to 29 into 965 0 by 108 into 3. So if we calculate this, is 863.73 seconds. This is 863.73 by 60 minutes. Therefore this is 60 minutes. Therefore this value is 14.39 minutes. 14.39 minutes. Now let us continue to find mass of zinc. So mass of zinc by mass of silver deposited equal to equivalent weight of zinc by equivalent weight of silver. So this is mass of zinc, this we have to find by mass of silver. How much we got? 1.45 is equal to equivalent weight of zinc is 32.5 by equivalent weight of silver is 108. Therefore, mass of zinc is equal to 32.5 by 108 into 1.45. This equal to 0.436 gram. 0.436 gram. Now to find mass of copper. So here mass of copper by mass of silver is equal to equivalent weight of copper by equivalent weight of silver. So this is mass of copper by mass of silver deposit is 1.45 is equal to equivalent weight of copper is 31.5 by 108. Right. Now this is mass of copper equal to 31.5 by 108 into 1.45. So if we simplify this, the value obtained here is 0.426 gram. 0.426 gram. So in this way we can find the mass of the metal deposited on different cathodes when different electrolytes are connected in series, that is when same amount of current passes for same time. So this is based on second law of electrolysis.